Okay, so on number one, what you want to do is obviously this is already in terms of cosine, so we need to multiply by cosine inverse so that we could get theta by itself. So whatever you do to one side, you do to the other side. So we've got cosine inverse of negative rad 3 over 2. So we know that cosine is going to be the x coordinate. And so the x coordinate is negative rad 3 over 2, which means we are in quadrant 2 or 3. And so we need to be able to identify that theta. And so this has, if you noticed that this angle right here will have a reference angle. So find it on your unit circle. And it has a reference angle of 30 degrees, both of them. So with that being said, we can know that theta is 150 degrees and also 210. Just because you know that this x coordinate is right here, and then we can finish drawing our angles. All right, so cosecant. Cosecant is needing to be rewritten in terms of sine. So we're going to flip it, right? So it's the reciprocal. So we're going to flip. We're going to rationalize it. So when we multiply by rad 3 over rad 3, we get sine of theta is equal to 3 rad 3 over 3. Rad 3 times rad 3 is just 3, so 3 times 2 is 6. And when we simplify that, we get sine of theta is equal to rad 3 over 2. So what quadrants are you in? So sine is positive in quadrant 2 and 1. Okay, so that's what I'm going to do. I'm going to draw this. So then this is the angle, and then the other one is right here. So what we need to do is look up on our unit circle, where is the y value? Rad 3 over 2. So what we need to do to solve for theta is to take sine inverse of rad 3 over 2. So I need to be able to find this, and we can tell that theta is 60 degrees and 120 degrees. Again, look at your unit circle. All right. Make sure you put your reference angle. This is 60 degrees, and this is 60 degrees. So that way we are drawing the angles correctly. All right, number 3, cotangent. It says solve each of the following, finding two values between 0 and 2 pi. So that means we're on radians. Solve these without the aid of a calculator, which means we need our unit circle. All right, so, and we also have our graphical analysis. So what we want to do is write this as tangent theta is equal to 1 over negative rad 3. Okay, and then we're going to rationalize. So we're looking for a tangent of theta at rad 3, negative rad 3 over 3. Okay, so remember what tangent is. Theta is, we're going to take first the inverse. So tangent inverse of negative rad 3 over 3. Tangent is negative in quadrant 2 and also in quadrant 4. So we're going to have this, and then we're going to have this. So we need to find our reference angles. Remember that tangent is y over x. So what we want to do is, there's a couple of ways to do this. We can look at the obvious ones where we have the two possibilities of being rad 3 over 2 comma 1/2, or the 1/2 comma rad 3 over 2. So if we were to look at this ordered pair, we would get y divided by x, which is the same thing as y times that reciprocal. And so we end up getting 1 over rad 3, which means if we were to rationalize it, we would get rad 3 over 3. So That is actually the ordered pair that we're looking for, but let's just say you didn't know that and we went through and did this. And we went rad 3 over 2 divided by 1/2. That's going to be rad 3 over 2 times 2, which just gives us rad 3. So we know that that's not what we want. So this is the ordered pair that we're looking for on our unit circle. So what radian gives you this? So if you notice that we're over here, the radian that's going to give you this ordered pair is going to be 5 pi over 6. So this reference angle is pi over 6, okay? And then this reference angle is pi over 6. So theta in quadrant 2 is 5 pi over 6, and the one in quadrant 4 is going to be 11 pi over 6. Okay. Secant. So it's the reciprocal of cosine. So that means where is cosine positive 1/2? So we're here. That means we've got this, and then we're going to go here. So we are looking for the x coordinate to be 1/2. So that's fairly easy now. We should be getting used to our unit circle. And so we could look at that and see that the x value is 1/2 at pi over 3 and at 5 pi over 3. The reference angle is pi over 3, and the reference angle is going to be pi over 3, okay? AKA 60 degrees. All right, let's take a look at number 5. All right, so here we want back into degree mode, and we're going to go to the nearest thousandth. All right, so you need a calculator, and we are going to go theta is equal to cosine inverse of negative 0.2419. When you do this in your calculator, you get 103.999 degrees. So think about where cosine is negative. We know that cosine is negative in quadrant 2 and quadrant 3. The calculator only is going to give you quadrant 2 measurement. So we know that that's one measurement. We need to be able to find the other one. So again, we're going to go 180 plus the reference angle. So the easiest way to find the reference angle is to take our 103.99 and subtract it from 180. And so we find out that our reference angle is 76.001. So if this reference angle is 76.001, this one is also. So that means we find the quadrant 3 theta by going 180 degrees plus the 76. And that is going to give us 256.001 degrees. And those are my two. All right, number 6. So we're going to go theta is equal to sine inverse of negative 0.2589. Sine is negative in quadrant 3 and quadrant 4. When you do this in your calculator, you're going to get a negative degrees, which just is helpful in many ways because, first of all, when we do this, this is our reference angle. So the 15.005 degrees is our reference angle. But remember, when we're drawing it in standard position, we've got this angle and then this angle. So 15.005 is here. The same reference angle as 15.005. So let's actually figure out quadrant 3 theta by going 180 degrees plus the 15.005. Okay? And then what we get is 195.005 degrees. And then quadrant 4 theta, well, that's going to be really easy. What we could do is go 360 degrees and then just subtract the value that we got in our calculator originally. So we are going to get 344.995. So those are the 2 degrees for number 6. All right, so now we are back into radian mode. So change your calculator. And so this one we're going to do is tangent. And we're going to go 1 over negative 1.280. So theta is equal to tangent inverse. And then put this into your calculator. Tangent is negative in quadrant 2 and quadrant 4. So when we do this calculation, we get negative 0.663 radians. So what that means, when it gives you the calculator value in negatives, then what it's doing is it's either going to give you the measurement, the first closest angle. So this angle is right here, which tells us it's the reference angle. Okay, it's negative 0.663 tells us to go this way, which is this angle right here. Okay, because it's negative. So we're going clockwise, which says if this is the reference angle, then this is the reference angle. So what we need to do is be able to calculate this angle. So quadrant 2 theta looks like it's going to be 180 degrees minus this angle, but we're in radians. So what we're going to go is pi minus 0.663. And that's going to give us 2.479. My quadrant 4 theta, well, the easiest way to do that really would be 2 pi minus the 0.663, and that's going to give us 5.620, okay, radians. All right, so last one here, we're going to go ahead and go theta is equal to sine inverse negative 0.6691. Use your calculator, and your calculator gives you a negative. So remember though, when your calculator gives you a negative, it's actually finding that reference angle. So the reference angle is 733.733, which means this one over here is also the 733. So we are finding quadrant 3 and quadrant 4. So quadrant 3 theta, easiest way to do that would be to go pi plus the 733. And we get 3.875. Quadrant 4 theta, probably the easiest way to do that is 2 pi and subtract 0.733. And we get 5.550.